So now let's look at this initial value problem. And once again, it um, doesn't seem easy to remove one of the variables by a simple substitutions. For example, if we try to solve this for y, actually it is. So if we solve this for y and substitute in this one, then y is eliminated and we do get um, everything in terms of x. And we can do it here because in this case, they are not asking us to do things in a certain order. So if we look at this problem, for example, they were asking us to do things in a certain order because they wanted us to eliminate x and solve for y first, and then later on get x. But in this case, if you solve this one for y, then y will be eliminated and you will be solving for x first. But we can do it here because if you look at the way they're giving the boxes, we can substitute any of them first, which was not an option in the previous problem. So yeah, we can do it this way. But look here, if you solve this one for y, then that won't work because that would have a term of x and a term of y. But you could solve this one for x, and then it would work because then you will get in terms of y only and substitute here. But you'll encounter a fraction, so it's a bit simpler if we solve the first equation for y in this case. So let's rewrite the equations. Dx over dt is equal to 5x plus y. And the second equation was dy over dt is negative 3x plus y. And x of 0 was 2, y of 0 was 0. Okay, so y is equal to x prime minus 5x from 1. So let's say this is equation number 1. So from 1, y is equal to x prime minus 5x, substituting in 2. So we get, so dy over dt is the derivative of y. So the derivative of y would be x double prime minus 5x prime. Is equal to minus 3x plus y, and y is x prime minus 5x. Okay, so now we'll bring everything on the left side. So you get x double prime minus 5x prime, and this gets subtracted minus x prime, so it'll be minus 6x prime. And minus 3x minus 5x is minus 8x, so it comes on the left, so plus 8x is equal to 0. And auxiliary would be r squared minus 6r plus 8, r minus 2, r minus 4, and r is 2 and 4. So x is equal to, so normally you have y is equal to, because we have a y prime and y double prime here, but in this case we have x's. So x is equal to c1 e to the 2t plus c2 e to the 4t. So we are given that x of 0, so let's look at the problem again. X0 is 2, y0 is 0. Okay. So if we substitute x0 is equal to 2, we get 2 for x, 0 for t, so c1 e to the 0, c2 e to the 0. So we just get that. So let's call it number 3. And now we find y, and then we'll be able to use the y condition, y0 is equal to 0. So x is here, and y is equal to x prime minus 5x. Y is equal to x prime minus 5x is equal to c1 e to the, okay, x prime will be 2c1 e to the 2t plus 4c2 e to the 4t. All right, I'm taking the derivative of this to get x prime. So, and then minus 5x be minus 5 times this, so minus 5c1 e to the 2t and minus 5c2 e to the 4t. So this will simplify. Oh, redo. Okay, for some reason, so let's just copy it over there. So right now we have x is equal to c1 e to the 2t plus c2 e to the 4t. X is equal to c1 e to the 2t plus c2 e to the 4t. And we also got c1 plus c2 is equal to 0. And we had y is equal to x prime minus 5x. So x prime would be 2c1 e to the 2t plus 4c2 e to the 4t minus 5c1 e to the 2t minus 5c2 e to the 4t. And this one simplifies to negative 3c1 e to the 2t minus c2 e to the 4t. That's y of t, and the y condition that was given to us was y0 is equal to 0. So you get 0 is equal to negative 3c1 minus c2. So let's call this number 4. And solving 3 and 4, c1 plus c2 is equal to 0. So from here, c2 is equal to negative 3c1. So substitute this in 3. 3 was c1 plus c2 is equal to 2. So c1 plus c2 means minus 3c1. is equal to 2, negative 2, C1 is equal to 2, so that gives us C1 is equal to negative 1. And then C2 would be negative 3 C1. C2 negative 3 times negative 1 is equal to 3. So we have both C1 and C2, and we have both X and Y. So X is C1 e to the 2t plus C2 e to the 4t. C1 is negative 1 e to the 2t plus C2 e to the 4t, so plus 3 e to the 4t. And Y is negative 3C1 e to the 2t. So negative 3C1 would be plus 3. And then we had negative C2 e to the 4t. So negative C2 would be minus 3. Okay. So X is negative e to the 2t plus 3e 4t. And Y is 3e2t minus 3e4t. So now you can also check whether these are solutions or not. So let's check the conditions, initial conditions first. X of 0 should be 2. So when you substitute 0 for t, negative 1 plus 3, that is 2. And y of 0 be 3 minus 3, which is 0. So the initial conditions are at least true. And then the derivative of x is 5x plus y. Okay, well. But like in an exam, you can check, whatever you have for x, you take its derivative and then find out if that does equal 5x plus y, and same for the other one. And then in the exam, once you have time to check it, there's no way you can get this wrong.